All right, Mr. P helps with Precal, Unit 3, Topic 3, Lesson number 5, Sums and Differences. Today we're going to be proving the sums and double and half angle theorems. So sine of 105 is the same thing as sine of 60 plus 45. So now we have it like this. As I showed you in the last video, we can now use these. So that would be sine of 60 times cosine of 45. Then that would be plus, because it's sine, it stays the same. So cosine of 60 times sine of 45. All right, so sine of 60 is square root of 3 over 2. And cosine of 45 is square root of 2 over 2. And then add that to cosine of 60, which is 1/2, times sine of 45, which is square root of 2 over 2. So this becomes, over here, this becomes square root of 6 over 4. And this over here becomes square root of 2 over 4. And then add those together, you get square root of 6 plus square root of 2 over 4 is your solution. I'm not going to really go over these questions again. Those are fairly basic questions. Rewrite the following using radian values. So only keeping it as radian values. So pi over 12 is really like 15 degrees, because pi over 6 is, pi over 6 is 30 degrees. So half of pi over 6 would be pi over 12, which would be half of 30 degrees, which is 15 degrees. And 15 degrees is the same thing as cosine of 60 minus 45. So cosine of pi over 3, which is 60 degrees, minus pi over 4, which is 45 degrees. And then you're just going to basically go through the exact same steps that I've been doing in the last video, which is the reason why I'm only going to do one of these. So cosine, remember, is always the opposite. So cosine of pi over 3 times cosine of pi over 4. And then it's going to be plus sine of pi over 3 times sine of pi over 4. All right, so cosine of pi over 3, which really in my mind is really thinking cosine of 60, which is going to be 1/2. And then multiply that by cosine, that'd be square root of 2 over 2, plus sine of 60 is square root of 3 over 2, multiplied by square root of 2 over 2. Okay, so then square root of 2 over 4 plus square root of 6 over 4. There's your answer. Square root of 2 plus square root of 6 over 4 is your solution. All right, so once again, solve just like we did on the last video. Only difference is I kept it as radians instead of changing it as degrees. But honestly, my brain works better for changing it to degrees. So we have tangent of this, and we're going to prove that this given identity is the same thing as this. So tangent will be tangent of x minus, because that's a minus sign, tangent of pi over 4 over 1 plus tangent of x times tangent of pi over 4. All right, well, tangent of x is tangent of x, so can't do anything with that. Minus tangent of pi over 4 is 1, so tangent of x minus 1. And this becomes 1 plus, well, tangent of x times 1 is still tangent of x. Now, if you look at this, tangent of x minus 1 is the same thing as this, and use the commutative property, and this is the same thing as this. So yes, we have proved that it is the same thing. This and this are the same. All right, so for the next one, sine of x. So sine, I'm going to use sine of x times cosine of pi over 2 minus cosine of x times sine of pi over 2. Okay, so sine of x is sine of x. Cosine of pi over 2, remember that's cosine of 90 degrees. Cosine of 90 degrees is 0. So anything times 0, 0 times anything is still going to be 0. So this basically just wipes out. Sine of pi over 2 is 1. So this is really negative cosine of x times 1, which just leaves you with negative cosine of x, which means this is the same as this. And that means that these two are equal as well. So just proved it. So I'm not going to go through all of these, but I'll go through quite a few of them. I know I'm only 5 minutes in. I'm going to change this to turn it into this. So cosine using this would be cosine of 180 times cosine of x. It's the inverse, so it becomes plus sine of 180 times sine of x. Okay, cosine of 180 is -1, so this really becomes -1 times cosine of x, which is negative cosine of x. Plus sine of 180 is 0. 0 times anything is 0. That cancels out, and voila, you have the exact same thing. I just turned the left side into the right side by proving it, verifying it. This question, all right, so I'll go through this one, but really it's just going to take a lot of steps in order to get the exact same thing. So sine of 30, so I'm using this bottom one down here. So that's sine of 30 times cosine of x. That's going to be plus, because it's, so keep the plus sign right there. So plus cosine of u, so cosine of 30 times sine of x. Okay, so that's all just this side. And now I'm going to add it to this side, which I'm going to have to do down here because I'm running out of space. So cosine is cosine of 60 times cosine of x. That's going to be the opposite, which is minus sine of u, so sine of 60 times sine of x. Okay, so let's see if I can go through this. So the left-hand side, sine of 30 is 1/2 times cosine of x, plus cosine of 30 is square root of 3 over 2 times sine of x. Okay, so the top line is right here. Now the bottom line, so if I add that to cosine of 60, which is 1/2 cosine of x, minus sine of 60, which is square root of 3 over 2 sine of x. Okay, now the positive square root of 3 over 2 sine of x and the minus square root of 3 over 2 of x, these basically cancel each other out because they're opposites of each other. And then you have 1/2 plus 1/2 cosine of x, so you have 2 1/2 cosine of x, which is your answer in this case. So 2 times 1/2 is just 1. So you're left with just cosine of x. Cosine of x is equal to cosine of x. They are the same thing. All right, so due to time restraints, I'm going to have to not do all of these. And let's just get to looking at the proving the identities, which I want to get to. So what if we double the x's? What if it's just 2 x's? Cosine of 2 x's is equal to this, which is really the double angle identity. This is the double angle identity. So I want to prove that this is the same as this. So cosine of x plus x, that's cosine of x times cosine of x minus sine of x times sine of x. So this is cosine of x, cosine squared x, so this is sine squared x. And then these two things are the same thing as this. So anytime you have double angles, that's going to be the same thing as this. Or you could say double angles is also the same thing as this, because you get the exact same information here, which is the same information here. Cosine squared x minus, so that's really the same thing as 1 minus sine squared of x using our Pythagorean identity. So I change this to this, and then subtract these two from each other, and I get the exact same thing. And then you can also do the same first step and just say it's double sine of x times cosine of x. So that happens to be the exact same thing as well, because it's 2 of the exact same thing. So it's 2 ways of writing. Okay, so this was sine though. So for sine, it's equal to double the same thing. So this is the reason why it makes sense. So here are your double angle formulas. Those are the 3 that I just went through just on the last slide. And then these are also your half angle formulas. All right, and that's where I'm going to stop. And remember, these formulas are always given to you. This is not about memorization. It's just being able to apply these formulas. Thanks again for watching. Have a great day.